So in our last class, we looked upon some of the formulas for calculating the average molar mass. Let us just recall all of that formulas once. So the first average molar mass that we discussed was the number average, that we denoted with the Mn with the bar over it. That was summation of the Ni upon the summation of the Ni. This can also be written as M with the bracket within a bracket. This type of the bracket we had to put in it. Then was the weight average, that was given as summation of the Ni Mi square upon the summation of Ni Mi. This can be written as this with the square M square within a square bracket. Then we discussed was the Mz, that we were writing it as summation of the Ni Mi cube upon the summation of the Ni Mi square. Okay, and the last one that we discussed was the viscosity average molar mass. There I made a mistake in writing the formula, so you just correct that once. That was summation of the Ni Mi to the power of 1 plus of the alpha upon the summation of the Ni Mi. This complete was whole raised to the power of 1 by alpha. There by mistake I wrote it that complete raised to the power of 1 by 2. That is not 1 by 2, that is 1 by the alpha only. So you just correct it once. Okay. So now we are going to move on to the next topic, that is our polydispersity index. This polydispersity index, it is defined as the ratio of the weight average molar mass and the number average molar mass. This is denoted with the D with the line in it, or it is denoted as PDI, that is polydispersity index. This PDI we write it as MW upon the Mn, where MW is our weight average molar mass and Mn is our number average molar mass. So it is the ratio of weight average molar mass upon the number average molar mass. Okay, so this complete this what formula we wrote for the MW. So the PDI, it will become, that is going to be equal to summation of Ni Mi square upon the summation of the Ni. This is summation of Ni into the Mi. This is MW's formula upon the Mn formula, that is summation of the Ni Mi upon the summation of Ni. So overall it is becoming like summation of the Ni Mi square upon, let me just write it again so it will be not completed over, get completed over here. So this is going to be summation of the Ni Mi square into the summation of the Ni. This is going to go into numerator, and in the denominator summation of the Ni Mi. This completes square, it is going to be there. Okay, so this is the formula for calculating the PDI, or we can write it as MW upon the Mn. So this is going to be M square. This I told that we can write the MW as the M square within this bracket upon the M within a square bracket, that is denoting our Mn, that is the number average molar mass. So if PDI is equal to 1, that implies that MW by the Mn, this is equal to the unity. This implies my weight average molar mass is equal to the number average molar mass, and this is the case for the monodisperse systems. So when PDI is equal to 1, such type of the system we call it as the monodisperse. Okay, when PDI value is equal to 2, that is PDI, it is equal to 2. This is for the bidisperse case, bidisperse. So in this MW by the Mn, this is going to be equal to 2. This implies the weight average molar mass is twice the number average molar mass. That means when this is the case, we call it as the bidisperse one. Okay, so how we can calculate this? PDI, what experimental techniques we can make use to find out this PDI values. So this PDI values, it can be calculated using the gel permeation chromatography is a technique that is used to find this polydispersity index values. So PDI is calculated using the gel permeation chromatography. Okay, so we need to just remember the name of this technique, that is the gel permeation chromatography, that is used to find the values of the polydispersity index. That will tell us the relationship between the number average molar mass and the weight average molar mass. Okay, so now next thing we have to look at is upon the graphical representation, that is for the fractional distribution of this weight molecule, a number of the molecules that are going to have a particular weight, that is the number average or the weight average. So how many fraction of the molecules are having such type of the weight corresponding to that weight? So that means we have to draw a plot for the fractional distribution of the molecules upon and their masses. That this graph we have to draw, that is for the graph, that is this, it is just like the Boltzmann distribution only, that is for the different types of the velocities we are having and the frictional distribution we get it from that. Similarly we are going to get here, that is for the friction of the distribution of the molecules and their corresponding to their weights we have to calculate this. So this is on the x-axis we plot their masses, and here we have is their frictional distribution. Direct graph is going to come in your exams, so you just need to mark which line is indicating which of the masses. Okay, so here it is frictional distribution. So for this we are going to get a Gaussian type of the curve, like I told, that is for the Boltzmann distribution. The same type of the graph we are going to get here, that this is a Gaussian curve like this. Okay, so let us just extend this one line. So here different frictions are there for the different lines, and this frictional distribution is corresponding to which mass, that you have to mark now. Okay, so here the lower one we have is, this is our number average molar mass. The second one line is indicating our viscosity average molar mass, and the third one it is our MW, that is our weight average, and the fourth one is denoting our MZ, because MZ is going to be the maximum mass. So corresponding to that, this frictional distribution we have to look upon. So that is why this MZ is coming on to the extreme right hand, and Mn there is only in the formulas. So from the formulas you can only see that it is summation of the Ni Mi upon the summation of the Ni. So this is the least compared to all of these masses, and the Mz, that is summation of the Ni Mi cube upon the summation of the Ni Mi square. That means in the numerator there is a cube of the masses. That means that this is going to be the maximum mass. Okay, and the MV, that is raised to the power of the alpha values are there in that terms.